So hello guys, my name is Smith Kumar and I have participated in the Level Supermind Hackathon in FineCoder.io. So this is the problem statement, social media performance analysis. For that, I basically built a web app over here, as you can see. So what and all things are over here is, first thing is that we see an insight over here. This is an insight that is generated by AI. And we'll explain later on how we are actually generating it. And over here is upload button from where we can upload the mock data. Let's say there is a specific format we need to follow to upload the mock data. Uh, like let's say I want to upload this one, so I can select it and open it. And it's saying error because the correct format is not available in that. Let's say I choose the correct one over here, which is mock data a1.json. So it'll start uploading it and it'll upload it in the data stack database. We need to wait a little bit and until it uploads, I'll show you a little bit of other things. So this over here, so it uploaded. Yep. So it'll refresh again. It will take a little bit of time to generate the insights and the database data. Just hold that. So before it comes, I will explain you how we are actually storing the data. We are storing the data in Supermind serverless database in database Astra. So the type of row we are using is ID, which is generated by data stacks, and then the post ID that we are using, post type, likes, shares, comments, and reach. So yeah, so these are all the tags that we are using for our JSON file and the data. So in order to so we got the data over here basically, and we are getting the insights also. So the insight is getting generated too. So what we are doing over here is we have basically created a table over here which says post type equals likes. So this is average data, bits average data per post basically to be precise. So it shows you know first the sort by we have also created a sort by button over here which shows we can sort it according to the way we want, like sort by shares. It will sort it according to the shares. Just all of the yeah. It's so it sorted according to the shares, like 281, 235. The same goes for this. This is per post data, and that is average data per post. So the formula that we are using to calculate this is very simple. What we're doing here over here is basically calculate taking the sum of the whole likes of all the carousel post types and dividing it by the total number of carousel post types. Yeah, the same we are doing for every other thing. So average engagement, we can select the formula for calculating the average engagement. Let's say we want to consider the engagement formula as likes plus share plus comment. We can use this. We can use like plus share comment by reach into 100. So there are three formulas that we can use. Over here, if we go, we can edit the weight of also like, shares, and comments, how much weight they carry. And if we select this, the weight will go to 111. So if we apply the formula, let me show you. So now we'll be getting the results of the engagement in percentage because we are also using the reach tag now. So if we click on any of it, we'll get a very good pie chart showing the reach and then the likes, shares, the comments, and the total engagement. And the same we can do for anything. And then we can see it post by post also. Let's say we want to see it for the carousel post over here. We can see what was the engagement rate for that post and like, shares, comments, and all the pie chart and all. And let's say if you want to see the overall summary of the average type, we can click on the show summary button over here and we can see the summary over here, like average likes 385, 408, 463. So these we can see average likes, average shares, average comments, average reach. This is like a pie chart of showing the average likes of all three and then average engagement. We can hide the summary and also now. Yeah, let's go the long list over here. Let's say we want to not consider the reach thing, so we can turn it off over here with the toggle button. So now it won't consider reach for calculating the average engagement. And if you see this formula also, it removes that other formula which is considering reach as a part of the calculation. Just hold on, give it some time. Yeah. So now we got the data in the number because it won't be in percentage because we are not using reach to calculate the engagement. So yeah, this is how we are getting it. Very nice representation. Everything. No, it's not showing the reach anywhere for engagement now. Yeah. So this is all about the website. Now let me explain you how it is internally working. So for database access, we are basically using data stacks, as I told you. So over here, we have basically uploaded a file from there, which is being shown in this collection, mock account data. So how we are using accessing it over there. So for accessing it, we have created another data stack lang flow. So as we can see over here, there is a StudDB component. We have put all the details over here. So find mock account data, the collection that we want to access, and then it will show the data. It will access the data from that database collection and over here, and we are connecting it with a data pipe over here. Pass data is basically for passing the data, like how we want to see it. For that, what I'm doing is I'm creating like a object kind of thing over here. Let's show the text. So it will convert it as an object. So for now, as you can see that it's not completely like a JSON file because it's not inside an array. So we are using combined text to put it inside an array over here. That will be the top uh, packet, and then that will be the bottom bracket. And if you see the combined text over here, now it looks like a complete JSON file. Yeah. So now we are outputting the text in this component. Yeah. So in order to access this, we go to the API, and we are basically using JavaScript. So we have put this in our code. If I'll show you the code, basically, this we have put in our code, last line flow client. So this is, and then run. So yeah, so this is the main data fetcher, the function which is responsible for fetching the data from the database, data star database, um, which we are accessing from this over here, API data, main data fetch. So we are accessing the database through a line flow um, component thing. And then how we are basically generating the insights over here. Let me explain that. But before that, let me explain you how we are using the upload data button. So when we click on upload data, it basically is what it is doing is mm, it go it calls this it goes to this route, request on this route, and what this route does is it takes the for as we are uploading a file, we are using multiple for playing around with the file, and then what we are doing is basically we are checking if the JSON is in the correct format or not. As I told you, there should be a post ID, post type like shares, comments, and reach column that is mandatory because then only we can do the calculations for our project. Yeah, so we are creating a data API client over here, and then yeah, these all things are the credentials basically, the collection name and all. And now first we are basically when we are uploading a new data, we need to delete the previous data. So we are deleting the whole data from the collection, and then we are basically inserting the data that we are getting from the file that I uploaded, and then inserting it in the collection, and then it will give us tell us the alert like everything is successful and all. And now, so this is how we are basically now. So till now, what I explained you is how the upload data button is actually working, and how we are actually accessing the data over here. Yeah, we are accessing the data to data stacks line flow in which we are using several database DB extra components to access it. Now, coming on to the main thing that how we are actually generating the insights. So let me explain you. So this is the insight line flow. We are using three. We are basically using an NVIDIA LLM, which is uh, second, which is a Llama 3.370B instruct model name of that component that we are using, model name of the LLM that we are using of NVIDIA. So what we're doing is we are taking the input of the average data basically, which if I show you correctly over here, this is the average data that we are getting from the server. Because for this calculation of the server database, we're calculating the average data and all everything in the server only, and from the client side we are requesting the data from the server. So in server only we are calculating the average everything. Let me show you. Yeah, and as you can see, average live average share, and we are passing two things over here, over here, normal data and average data. Normal data is for this one, and average data is for this. Yeah. So we are taking this, and we are basically sending a request to the data stack Langlo through this chat input. How we are doing that? Again, we are using API for the JavaScript API. Okay, and in this API that we are using over here, we are basically, one second, let me show you. Yeah, there is a separate route for that. So we are requesting this route fetch insights route, and which takes an input value. Input value is basically the average data that we are passing. Um, so this is the function that we are calling fetch insights JSON stringify average data, and this is the function that we created to call the API fetch insight request, and we are getting a response from that as an insight. I will explain you how we are actually getting the response now, and this is the thing. And over here is the main insight fetches that is given by this API column only. So we're using that, we are passing input value as the average data. And so this chat will be filled with the average data that we're getting, which is over here, this data. And then what we are doing over here is we are basically combining this data with the first text over here. The first text is give 3 to 4 insights based on the following data. Insights should be simple, small, and non-explanatory. So we want the insight to be non-explanatory. So we're basically creating this is not a prompt for now. We're just giving a request, input request. Now the first prompt is we're basically using the prompt chaining. We are using several prompts to fix the data, re-verify it, and then get the best outcome at the end. So first we're using this prompt over here. So we are using this is the kind of this is the first prompt that we are using. So we are passing our input as a JSON data, and it's going to structure the response like this: insert 3, and like so. Just doing it that to first create the insight. So if we basically run it over here, uh, the test is not. We just copy the. For example, if we just copy this from here and just paste it for checking purpose over there. Oh, that's what we did. Now if we run it, so this chat input will go and combine with that, and then it will look like this. I'll show you. The input will look like just give some time. So we're basically using NVIDIA LLM for this because it's free uh, and open source. It's pretty easy to use. So we started building. Let's build now. So we can see the text over here. First, I will show you this. This is how the combined text is looking. So this is filled. This is filled by the client side and sends a request to the server. This is how it looks. And the server sends a request to the Langflow API. And this is the prompt. And if I show you the output over here for this first LLM output, it looks like this. Insights scarcity poster 24, and it's generated several insights. And then I am also telling it to generate data, the previous data. and write it over here so that we don't have to pass it the data again because we need to re-verify it with the next LLM. So in the next LLM that we are using over here, we are passing a prompt and we are telling it your task is to evaluate the insights generated by the previous user and verify if it's correct or not. So it's getting the input data and the insights created by the previous user is passed to you. So the input data is passed and the insight is passed. Now this LLM again re-verify the data and generate a final response of insight and insight from insight, whatever the insights are. So if I run this to the second LLM that we're using, so now if we see the text over here, you can see the insight one is Carousel post 3.87% higher. So we are getting the data kind of insights that we wanted, but it's not in a interest. It's not written in a interesting way, and it's pretty big. It looks pretty big. So what we are going to do for that is we are taking another prompt for that, which will write it in a very good English and write it in an interesting way so that when the user sees it, it understands very clearly what is happening. So I'm telling it a culture insights give to the previous user. Write those in more interesting and appealing but shorter way by using words like drives more than how much percent, etc. And then correct insights. This is the input that we're getting. This structural answer is following the array. So we are structuring the arrays like show. This is the third and the final prompt that we are using to get our final data. So if you run it over here, the third LLM will basically convert the data into a very interesting way of vocabulary. It will use some English things to make it look better. And it will also convert the insight into an array. As you can see, please structure your answer as following in an array. So it will convert the insights into an array so that it will be easy for me to use it on the client side to uh, you know represent this in the cursor as an insight in top. So if you see the text over here, as you can see, we're getting basically what is this is we're basically getting an array of 4 insights that we wanted, and it's using pretty good English over here, as you can see. So now we got this component and we are passing it to a chat output over here. This we can't see, but we can access it. If you see, then yeah, this is the text that we're getting. Once again, I didn't build it. Give me some time. Build it actually. So basically, this is how we use GPT, basically NVIDIA GPT, to generate insights by using prompt chaining and for storing data stacks, storing data in data stacks and querying the data. For querying the data in from data stack using another Langflow, we can go with direct uh, querying also using the data stacks API. But just wanted to use the Langflow for this. Pretty good. And we are using actually the API for uploading the data and deleting the data from the extra database. So, yeah. So these is all basically it's taking a little bit more time to build. I don't know why. So this is basically the whole setup over here. This is the prompt chaining that we are using for generating insights, the Langflow flow, and this is for querying the database and for deleting and the replacing the data, uploading the data in that we are using the direct API call that I already shown you over here. Yeah, we're basically creating a client over here, data API client, basically a client, and then we are deleting and inserting everything in that. Yeah, so this is how it looks. Website is pretty straightforward. At the center, it shows the insights. Upload button is over there, and this is how it shows the. If you want to see get a very good understanding of the data, we can click on that, or we can click on this to get a per post engagement data and pie chart. Very good pie chart over here. Yeah. So this is it. Thank you for watching.